Yeah, so that's really one of the unique things about PostgreSQL community, that it stands together, and even though there are differences, every organization who is contributing to Postgres, they have their own agenda, they have their own wish list, if I may say so, but they still collaborate a lot. Like parallel queries, I think, is one of the best examples that I can come up with. A lot of groundwork was done by Robert Haas and team from Enterprise DB. Then first parallel feature, I think, was added by Enterprise DB's Robert Haas and team, Amit Kapila. And then based on that, in the same release, there were a couple of things added by second quadrant guys. And then on top of that, a lot of other improvements were done by a lot of other contributing organizations. There is a particular discussion going on online checksums, where Steven and Robert, Tom Lane, these all guys are very actively participating, all from different organizations. So that's one great thing about Postgres community. All right, guys, you will see a lot of me talking about Postgres. You'll see a lot of me talking about the sponsors of this conference. You will see a lot of me talking about attendees, talking about speakers, about other committee members. But this is my space. Now, this next 50 minutes, you're going to hear a lot of great stuff about me, all the great things that I'm doing. So if the slides are not good, or if anywhere you seem to think that I'm not prepared enough, that is because I completed these slides yesterday around 8 p.m. in the night. I started working on them about 10 a.m. yesterday morning because one of the speakers could not make it to the conference. His flights got canceled, and then I'm his fill-in. I'm filling in for that person, okay? So please bear with me if the slides are not great. I'll update them before I upload them to SlideShare, okay? So about me, I'm primarily responsible for spamming your mailboxes, urging you to come to this conference. I'm also responsible for all the feed that you received in your Facebook, LinkedIn, Twitter, that were basically all the paid advertisement that I sponsored, that I encouraged Sakshi to do, to keep on bombarding you guys with a lot of Facebook feeds about the conference. And since this food was great, I'm also responsible for that. This is the last time I'm using that joke for today. And yeah, apart from technology, I also am interested in cycling, or I love cycling, I would say. Or I would have myself believe that I love cycling. Even though I don't go out cycling, I believe that I do love cycling. I love football. I try to play every weekend. Not very good at it, but I still try to play. Apart from this conference, I'm also involved a little bit in Postgres conference Down Under. So if any one of you is in Australia around November, that is when the Postgres Down Under happens. It's a great conference, same kind of conference, but in Australia. So if you are based out of Sydney, please, or if you have colleagues, your friends in Sydney who love Postgres, advise them to go there. It's also a great conference. Apart from Postgres, I also work on, I forgot I don't have to move. So apart from Postgres, I also work on some NoSQL databases and some container technologies as well. I'm not going to talk about Ashnik, who is my employer. I'm not going to talk about that they work on a bunch of other enterprise open source stuff. I will also not talk about how we work with government agencies and enterprises in Singapore. I'm absolutely not going to talk about these things, okay? That some government agencies and large enterprises are Ashnik customers. I'll not talk about it at all, okay? We help customers move Oracle databases to Postgres. I'm not going to talk about that either. I'll also not talk about how I can help you adopt PostgreSQL if you pay me some money. I'll not talk about that. I would be talking about Json. I would be talking about why Json and how to use Json. in your own use cases. What kind of use cases are best fit for JSON? So cases where you could use JSON is where you have data model that is complex to be represented in relational format. So that is one area where you could use JSON feature. What I'm trying to say is don't use JSON just because you can use it. And a lot of people try to use JSON just because the feature exists, and they end up using JSON. And usually the way they would model their data in JSON is pretty much relational. You would have just 6 fields, no nesting, no arrays. Then probably you don't need JSON. You can just live with relational databases, or just live with the relational tables rather. And Postgres offers both of them, so you don't have to compromise one for the other. So if your data is truly relational, maybe you're better off storing them in a table. But if it is hierarchical, if it is not very easy to represent as tables, then you can use JSON. It also offers flexibility in schema design. Or if you have a NoSQL database like MongoDB, for example, and you want to use an FDW to talk to that MongoDB database, or you have some data which is in a different kind of NoSQL store, also represented as JSON, and you want an FDW to talk to it. And also, if you are having some kind of use case where data is incoming from some sources and it is always in JSON format, you first want to store that data as it is and then process it. That is another great use case for using JSON features of PostgreSQL. And like I said, don't try to convert your relational data into JSON documents. You need to remodel your data. You need to think about how it would look like, how it would really fit as a JSON. So nesting, arrays, those are ways to go. Try to denormalize your data structure a little bit. Don't pick it up as it is and try to store it as normalized JSON format, if I may use that phrase. Try to keep those things which are fetched together. So you have one JSON document which has everything that you are going to mostly select as one entity. Don't try to spread it across multiple JSON documents. If your schema is pretty much fixed and you know that it is going to remain that way, then use columns. Use native column data types. Store them natively, because that might be a more efficient way to access and also join and do subqueries in them. And that does not mean that Postgres does not support these features when you're using JSON. It is just that it makes your queries a little less efficient. Also, if you update more often, or if you fetch data more often based on some predicates, think about using JSONB and don't use, let me enable. Yeah, use JSONB and not the typical, okay, yeah, use JSONB and not the typical JSON data type. Yeah, there are a few use cases like when you want to have native JSON schema and you want to use ACID transactions. There's a great use case for using JSON feature in PostgreSQL. Also, if you want to transform your relational data before you send it out to your application. So you can have an application which has an API which talks to the database, but it is all microservices based or SOA or whatever you want to call it, your design pattern. Basically, your API needs to talk to the database, get the data out, relational data out, convert that into JSON, and then throw it back to the calling API or to the calling module. That is another great use case where you can utilize Postgres JSON features. Postgres has a lot of JSON functions and operators that allows you to convert this relational data into JSON. Another great use case is when you are going from something relational like Oracle AS400 DB2 to a NoSQL database. Now, you can use Postgres as a stage area for doing all the ETL. ETL tools are not that awesome at producing JSON from relational data, especially when you have to do a bulk transformation, like 1 million rows, you have to transform that into JSON. ETL tools would not be able to keep up with that kind of volume if you are doing that kind of bulk transformation. In Postgres, I can easily write a stored procedure or a view which does exactly that. And I did one of these things for a customer who was going from AS400 to a NoSQL database, and there was absolutely no other efficient way. So we utilized Postgres in between, which does all this transformation and converts all the relational data into JSON data. And it works amazingly fast as compared to an ETL tool. So let's talk about first kind of use case, relational to JSON. All these examples that I'm going to show you, they are based upon a particular database. It's called Pagila, or sorry, if someone, Pagila, which is like a DVD rental store database. It is based on Sakila, which is a MySQL example database, and Pagila is a PostgreSQL conversion of the same with slight bit of modification, I believe. It's a DVD rental store kind of database which has entities like film, actors, and then they get combined with each other based on a many-to-many relationship. So you have a table called film, you have a table called actor, and they are both joined with each other by a third table called film actor. So you would write a join query which is spanning across 3 tables to join all of them together. Multiple movies in different rows, one-to-many. So one movie can have multiple actors. And if you want to convert this data, so if you want to have a movie dump, like have all the movie data, convert it into JSON. One JSON document for each movie. Basically, it should contain information about the movie, the title of the movie, what language is it in, some description about it, and also have information about the actors which appeared in that movie. If you want to have that kind of structure, you could use row to JSON. So the same join query that I have here, I would just put it inside a function called row to JSON and try to get output out of it. But if you really did that, what you will see is you'll get something like this, not very helpful, because the field names are like F1, F2. What you need is actually the column names to appear as your field names in the JSON. So you have to take a slightly different approach. You have to tweak it slightly. So you would call it on a result set. So you can call this function on a result set. That's what I'm doing here. This whole query, I have put that inside a nested subquery. Whatever is the result set that I produce here, I call this row to JSON function on top of this result set. And then the output that I get is a proper JSON document, like what I would want. Again, there is one slight bit of problem here. This is not how I want my APIs to send data out. What I want is one movie, one JSON document, and all actors should be added as a nested JSON document, as an array of nested JSON documents, right? This is not really helpful. Even though I have a proper JSON document, but I have same film, same movie repeated 3 times. This is not what I want. What I want is a single document. So we can use JSON aggregate function and with a subquery. So I would have a subquery inside. This subquery is exactly fetching the relationship between movies and the actors. And then I'm aggregating them as a JSON aggregate. This aggregated function, this aggregated output is then combined in a whole result set. And then on top of that whole result set, I'm calling row to JSON once again. This is which should get me more or less to the point where I wanted to get. So I have a lot of actors as part of this movie. All of them are in a single nested document. If you can see, this is a nested array of all the actors. Okay? Don't worry if you don't recognize these actors, they are all fake. Okay? It took me a while to figure this out, that they are all fake. So, all right, now you can also set the pretty flag. So you can set a pretty flag that would mean that the JSON output is going to be a little bit better formatted. Or there is also another function which does a pretty formatting of the JSON output. So you can just call that function and it will have a very nicely indented view of the whole JSON document that you're trying to view. What if I have nulls? For example, there is a, maybe there's a movie about Postgres conferences, and that features me and my peers who have tried to put this conference together. Samir and Sakshi, she's trying to arrange the coffee over there. So imagine if there is a movie which features both of us, and she does not have a last name. She just have a first name. And that is really, by the way, she just have the first name. So now, if I try to fire the previous query again, I would see that the last name is null. And this is exactly the kind of output that I would receive. This is, though theoretically speaking, OK. But in typical JSON parsing, this could sometimes pose a problem, because JSONs are not supposed to have null. If a field is null, the field is simply not there. Right? The concept of RDBMS null does not exist in the JSON world. So to get rid of such nulls, you can just use JSON strip nulls. That is a function that allows you to strip all those fields that have null values. You can pass it you can pass it to a whole JSON document, and any field which is set to null will be removed. There is one slight bit of challenge that you might face. You could come across arrays which are empty, or you could come across a nested JSON document which is empty. Now, that is very different from null. If you come across a nested JSON document which is just empty, this function still would not strip it. In that case, you can use a different function called null if, and you can pass wherever you have those nested documents. The query like what I have here is, over here I can pass null if, and I can say null if it is empty brackets, then just use null instead, and don't produce empty brackets. Because if you ended up producing empty brackets, those are different from nulls. And then strip nulls would not help you. Now, that was one use case, which was many to many. What if I have a different kind of use case? What if I have a one-to-many relationship? Should be more straightforward, right? For example, I have staff and address. So in the same database, same example database, Pagila, there is an entity called staff, rental staff, who is renting out DVDs, and their address. So it is one staff will have one-to-one is having a one-to-one mapping, or it could be a one-to-many mapping as well. Now, we know that how we can use row to JSON, so we got that bit correct. We just fired it on top of the whole result set, and we are passing the Boolean value true, which basically is going to pre-format the JSON output that is produced by row to JSON. Now, if the address, now here the address is selected as like individual fields. What if I want address as a nested document? What I want is the staff ID should be there, but their respective addresses should go as a nested document, something like this. So what I want is something like this. So I could do, So I could do something like this, where I do a row to JSON inside the whole statement once again. So I'm using a nested query here, which would allow me to do that and get this kind of output. Now, this slide is slightly misplaced here. It should not have been here. So this is what I was talking about. I'll change that before I upload to the slide share. Now, I used a nested query here to convert a document which is inside another document, right? what if I could avoid doing a subquery? How can I avoid doing a subquery there? There is another function called JSON build object, to which you can pass input arguments, which could be a column value, which could be a literal value. You can pass it values and then build documents on the fly. This allows me to build a document. So basically, it says that use address as the label and the value coming from the column address as its value, and use address 2 as the label, and use address 2 column value coming as the value of that label. So I can build a document simply by using this function, and I don't have to use an inner query, which simplifies your explain plan by a great deal. So you don't have to do a nested join or a kind of a join or a subquery that would be performed if I use the previous query. Any questions? Okay. Sometimes you might have to combine 2 columns together. So maybe like you have a home phone number and you have an office phone number, and you want to, these are 2 columns, but you want to convert them into an array, or you want to convert them into a nested document, right? Or you have like address of stores, or address of your distribution center, and you want to add location tags to them, and these location tags will be city and the country, or maybe the state as well, but all these are stored in different columns. How do you combine these columns together as an array? So that is pretty straightforward. You just have to use JSON build array. That's just a function. Pass all the values to it. You can again pass a literal value, or you can pass a column, and then it will apply to each and every row. And for each and every row, those 2 values will be combined together and put inside an array, something like this. So you have got a field called location tag, which is values Canada and Lethbridge, country and the city. So they are combined together as an array. Okay. Now we have completed part of the problem, which is basically if you are, or one type of the problem where you have relational data, you want to convert that relational data into JSON, and your application is returning JSON back to other modules like microservices or SOA kind of application architectures, where you have modules talking to each other and exchanging data in JSON format. But the other type of the problem could be where you are collecting data in JSON format. So you have incoming data that you have to collect and then process it, or you are storing data natively in JSON format because you have thought that JSON is the best representation of your data. How do you process that data? How do you fire select queries on top of that data? So can you guys see this? Yeah? Okay. So very simple use case where you have a table and it has got a JSON-B column, movies info, and then I can just insert a whole JSON document in that column. A complete JSON document, well constructed, formatted JSON document inserted there. Use JSON-B as much as you can, because then the data is on disk. See, from the interfacing perspective, it is not much difference, or the representation perspective, it is not much different from JSON. But when you store it on disk, this data is very nicely stored as key value pairs, and when you want to query this data, the parsing becomes very easy as compared to parsing a JSON data. So if you have JSON-B columns, your select queries based on certain fields within the JSON document, or your update queries, all that would work much better as compared to a JSON field. So use JSON-B as much as possible. There are some use cases when JSON could be better, but those are very few. And the difference is not really great from the kind of use cases I have seen. So let's look at some more sample data. So this is one kind of sample data. All that output that I produced from movies, all the joins that I was showing you, I'm going to insert into this movie dump. Similarly, I have got some dump for JSON store as well. So all the store locations, I'm storing them as a JSON. So store ID and the address, which is a nested document, I'm storing it as individual JSON documents. So I have got 2 rows in this particular table. Both of them has a JSON document. And by the way, JSON and other kind of columns could sit side by side. So you can have some columns which are integers or varchar or varchar, depends on which thought of school you belong to. The thought that says varchar or the thought that says varchar. I like both of them. So yeah, so if you have varchar columns, integer columns, float columns, they can sit side by side with a JSON B column, and that is absolutely perfectly fine. And I have got another table which has got a JSON column, which is staff. So this again has got 2 rows, staff details like the email address and their actual address, which is again stored in a nested document. So if I want to get specific values from the JSON, like I want to just get the city, so I can pass the whole path where the city is stored. In this case, city is stored as a nested field inside the address field. So I can pass a complete path here. This is an operator that tries to parse the path that you have provided. And then I can get this output out here. Pretty easy. Or I can just try to get a particular field as well. So I can also try to parse it by a particular field value, like store ID is one of the fields inside the JSON. So this operator that you see here, hyphen and then 2 angular brackets, that tries to go to a specific field inside the JSON and get its value. You can also use JSON populate record to convert your JSON data into a result set. So I have got JSON data in this particular table, store JSON dump, and I'm converting that into a record set. I have to specify the type of that record set here, which is basically store record. So I have another table or a type defined where I have defined these columns, these 2 columns, and that is what is being used by over here. Now, what if I have to get I have to use some kind of predicates, which is based on the where clause, which is trying to access the JSON document, or a field inside the JSON document. All the movies where Nick Wahlberg appeared. I can use this containment operator, which tries to say this particular field should contain this value. This particular array field should contain this value. Or all the movies where Oliver Kuba and Cronin Ann have appeared. I don't think they are real actors. Has anyone heard of them? Yeah, okay, I thought so. So then instead of just passing 1 value, I can pass 2 values here, and then it will try to make sure that only those JSON documents are returned wherever the array film cast contains both these values. Pretty easy again. I can also try to get all the movies where someone from the Wahlberg family. So if Wahlberg is a last name, I want to find out all those movies where someone named Wahlberg has appeared. So I can just use the containment operator again, but instead of specifying both fields, I just specify 1 field. So this is a very powerful operator, especially when you are working with arrays. Now, another place where people talk about using JSON feature is in agile development. So what you do is you start with an you start with a JSON column. How many of you work in agile methodology? Pretty much everyone, I guess. Yeah. How much of you actually do agile? That's a tough one to answer. Yeah, I know. And on the records, no one would want to answer that. So now, especially it becomes very difficult when you're talking about agile in databases. A lot of people, when they're using this, a lot of people try to use Postgres in that way. You use a JSON column where you put in fields, you throw in all the fields while development, and then you try to take those fields out as a proper column when your code has matured or when your requirements have firmed up. So let's assume that city is one such column that you want to take out. You want to take out city and make it a new column in your table and remove it from the JSON. You can easily do that. Update would be pretty straightforward. You use the path operator to set the value of new column to the path of address comma city, which is basically inside my JSON. I have a field called address, inside which I have a field called city. So parse that path, and whatever is the value, set that value to my column. Once I do that update, then I can go ahead and use the path difference operator, which is like you're trying to subtract something from the JSON. Okay? You have a JSON document. Go to the path that I specify here. So this is the path I have specified here, and subtract that path from my JSON document. So whatever value is stored at that path, that field is completely removed. So within my JSON, I have a field called address. Within address, I have a field called city. This field will be taken away. The field called city will be taken away from my final output. So if you look at it, if I try to select data, you will see the city has been completely removed. There is no field called city inside address. And here I have a new field called city in the table itself. Okay? But well, in agile, people also focus on failing fast. Right? Isn't that one of the principles of agile, right? You try to identify issues before they actually become an issue. So let's say that you identify this, you finally figured this out, that this is a problem and this is not working as I had expected, and my APIs are now breaking down everywhere. So I want to now bring this back into the JSON, and I want to drop this column called city. You can again do that very easily. You can do that with the oops, where is that? With the JSON B insert. So you can use JSON B insert to insert a field inside a specific path. It's not just inside the main document, but also if you have a nested document, you can utilize this to insert a new object. You can also use concatenation. For example, if you want to insert something in an array, you can use concatenation operator. It perfectly works well with JSON B arrays. And yeah, so then finally you'll see that the city has been added back here, and then all you have to do is go ahead and drop that column. Okay, now whatever I have been talking so far sounds all good. You can insert data, you can process relational data to JSON, and other way around, you can get the JSON data out. You can query based on JSON fields or nested fields as well. But how efficient are these queries? Can they really perform at the same scale as a relational, as a normal relational query would work? So let's try to take a look at that. Just before getting there, how many of you use JSON today in PostgreSQL? Right. This is a question I should have asked in the beginning, right? No, it's good to ask this question now, because now I would like to understand how many of you think you're using these functions today? Are any of you using these kind of functions today? Okay, great. And do you guys use indexes as well? Yeah, of course. You write some of those functions, by the way. Yeah. So any of you using indexes? What kind of indexes are you using today? Inverted indexes, gin indexes, okay? Rum, yeah, rum, vodka, those are extensions, right? Yeah. Guys, we are not talking about drinks here. Gin, vodka, rum, these are all kind of indexes that exist in PostgreSQL core or by means of some features, extensions of PostgreSQL. Yeah. And some of them are really popular for Json data types. Well, you can also create B-tree indexes on JSON fields, and we'll see that in a while. And they can work more efficiently as compared to a gin index or an inverted index or vodka or rum kind of indexes in some use cases. For example, if I have a column, let's say I have a table called film, and I fired a query based on ratings. And if I create an index on rating, it would perform much better. I would get benefited by the index scan based on the index. And let's see how it would look like in case of JSON. If I have a similar data stored in JSON, I could create an index on the expression that I'm going to use most of the times while filtering. So if I'm going to use a straight field query, like the one which I was showing earlier, if I'm going to use that, then it is pretty straightforward. Just index this whole expression itself. And then when you query based on this expression, it is always going to use that index. Okay? So it is quite simple. Whatever expression you're going to use in your where clause, you can just index that expression itself. Postgres supports expression-based indexes for a very, very long time. And whatever expressions you plan to use, you can just use them in JSONB. Now, again, going back to, I'm not trying to take a dig at Agile, but yeah, it goes back to the concepts of Agile that you may not have everything clear up front. Your requirements may not be clear, right? So what if you don't know which columns are going to be used in your queries? In that case, at least you would know that what kind of queries or what kind of query operators you would use. Now here I know which kind of query I'm going to fire, both the field and the operator. But what if I didn't know that? Then I could create an index which is basically a gin index, and I can provide the operators as an extra argument to specify what kind of operators would be utilized for this kind of indexes. Now this makes pretty much every field queryable, or you can use any field as part of your predicate, as part of your where clause. So which means you can fire a query like what I was trying to fire earlier. But here's the catch. This is very much based upon very specific operator class. That means an operator like this would not work. So over here you can see that it is still doing a sequential scan. You have to use a very specific operator which falls in this operator class that you specified here. I know that one of the operators is a key value match. So this is an operator which tries to match a key value pair with one of the key values that is specified in your JSON document. Rating is one of the keys that I have in my JSON, and its value is PG. That's what I'm trying to match. So this is the kind of operator, and this is the kind of query that I would use, a key value match, and not a path match or not a field match that I'm doing here. This would not work out. Now, going back to what is coming up, Stephen covered that, so I'm not going to dedicate a whole slide to that. There is path expressions that is coming up in version 12. A lot of these indexes that we spoke about, even in the path-based expressions, the expression-based indexes would still work. So path-based expression basically means that if you guys are familiar with, or if you guys have used XML queries in SQL? Any one of you have used XML query in SQL? X queries? Yeah, they are very neat path-defined operators. Now, the thing with JSON is Postgres was perhaps the first relational database to come up with JSON features.
Yeah,
I think so. And that is why there was no SQL guideline around it. It came up recently after a couple of other commercial vendors also started adding that feature. One other open source project started adding that feature. So SQL committee felt the need to have a standard around it. So they introduced expression path and everything. So Postgres, as soon as it has come out, Postgres folks started working on that, and they have come out with that patch, and it will be available in version 12. So these kind of indexes you can still create when you know what kind of query you're going to fire. Still, the patch that would support something like this, where you can just create one index that allows you to query any of the fields based on an operator like this, that is still not out there. That patch, I think, is still pending. I saw there were I saw it in the mailing list as well as on a couple of social media forums as well, that this patch is still not in for the index users. So even though the expression-based path-based expression queries are going to be supported in version 12, I'm not entirely sure if they would be able to utilize indexes or not, because the patch is not in. Very likely the patch would be in before it comes out. We still have a lot of time left out. But in case if it does not make it, you can still make use of B-tree indexes. You just cannot use the GIN indexes, but you can still make use of B-tree indexes and index specific columns, rather the fields, specific fields of the JSON which you want to utilize. So that's all about the talk. If you want to know more about what I do for my day job, or if you have any question about PostgreSQL, or if you're happy to pay me for consulting for PostgreSQL, please feel free to reach out to me, and also other NoSQL databases. You can reach out to me. He didn't hear that. And yeah, if you have a query, drop an email to me. Also about the conference, if you would like to be a part of the conference team, we are trying to, we are still thriving, and we struggle a lot to put up this conference. And it would be much more easier if we have more people who are part of this team. So if you guys are interested in being part of this team, please feel free to reach out to me via Twitter or Gmail. Drop me an email. I try to scribble a bit. I'm not very good at coding, but I try to scribble a bit. And whatever I do, I put it on my GitHub. So if you guys are interested, take a look at that. Please go ahead. Any questions?